All right, so for this example, we have sociologists that found that 45 retired men had an average of number of jobs during their lifetime about 6.8, and it happened here. We know that the population standard deviation is 2.1. Just want to go over a couple of indications here that we don't know. They didn't give us what type of distribution are we dealing with, right? So they never say it is a normal distribution or such a thing. So we don't assume this distribution is normally distributed. Therefore, we have any distribution. So if I have to graph it, it will be like any distribution we don't really know. All right. And what's going on with this, they gave us two pieces of information. They gave us the mean, all right? So the mean is going to be 6.8, and that's what they gave us the sigma, which is 2.1. All right, so the fact that they made a sample of 45, all right, now we are in the domain of central limit theorem, all right? So the new distribution, once you do sampling, it will be a normal distribution, all right? And according to the central limit theorem, this is by the way, this was the x-axis, but whenever we do the sampling, this would be the x-bar axis, all right? And the new distribution, it will have a mean, which we're going to be called mu x bar, and this is going to be equal to 6.8 as well. However, the sigma x bar, it will be equals to the sigma divided by radical n. So in our case, it's going to be 2.1 divided by radical 45. Now, going back to the question, they are asking here, find the best point estimate of the mean, all right? So we are talking about the mean of the distribution, right? And remember, this is 6.8 is the average of the 45. And because we are having the mean here, this mean, and the mu x, they are equal to each other. So then we can assume that they are equal to each other, right? So here, the only thing we should do is just type 6.8. That's the best estimation we have, right? All right, so the first one is good. Now we want to find the 95 percentile confidence interval. All right, so for this 95% confidence interval, we are talking about the sampling distribution. So we are not talking about the original distribution. So we are talking about the 95 percentile confidence interval after the sampling, which is right here. All right, so we are talking about this. So if we have 95% here, if I have 95% in this area, so this area can be 95%. All right, let me put 0.95 here. So the remaining area would be 0.05, and that's going to be separated in two tails. All right, so it's going to be this tail over here and this tail over here. So this area should be 0.05 divided by 2. So how can we do it is basically there is a formula here. It's always equal to 1 minus c divided by 2. All right, what is c? C, the confidence interval. All right, so this is 0.95 for us. All right, so that's what they're going to give you. So now, once we figure out this is 0.025, I can add a 0 to make it 4 digits. So we know already what is this area We know this area already. And that's all what we need. We need the left tail area in order to use the calculator. So obviously we're gonna look for the confidence interval, and what we're gonna do is we're gonna use the calculator for this mean. All right, so I don't want to go through a lot of calculations, so I'm gonna go to distribution, second function, distribution here, and then what I'm going to do is I'm going to use inverse normal. We are using a normal distribution. Well, there are two conditions here that are satisfied. That's why I'm using normal distribution. First of all, the n is going to be 45, which is greater than 30. All right, and as well, we know sigma is going to be 2.1 is known, and this is a population distribution, right? So these two factors allow us to use a normal distribution. All right, then what I'm going to do, I'm going to go to inverse normal, enter. So here is I'm going to enter the area, and ours is going to be the left area. So if I want to find this number in here, all right, so if I'm looking for this number, what it might be, remember this is 6.8. all right, so I'm gonna enter 0.0250, so 0.0250. now the mean, I am talking about this distribution, all right, mu x bar, so the mean is going to be 6.8, and the sigma is going to be 2.1 divided by radical 45, so this is going to be 2.1 divided by radical sign, so radical sign right here, so second and square root, and then I put 45 in there, close the parentheses. So I'm done with the filling up the information, required information. I go enter again, and this is going to be 6.186. 6.186. I know how many digits I have to round, so I hope it's 2. We'll see later. So now, once I'm done with this, I need to figure out the other boundary here. So let me zoom in. So I want to figure out what the other boundary here, and I need to figure out this number. In order to figure out this number, I need to know the left area, which is this area over here. So the calculator takes only the left area. All right, and this left area, it will be 0.95 with the area of inside plus the 0.025. So this is 0.025 and this is 0.095. 0.95. So 0.95 plus 0.025, and this is going to be 0.9750. So I'm going to go back again. So second and vars, and then I'm going to go to inverse normal, and then I'm going to change only the area. So this is going to be 0.9750. all right, and everything else stays the same, and enter, and this number is going to be 7.4135, so I'm going to put 4. all right, okay, so let's go to the question, and they want to round the final answer to 1 decimal place. all right, so the first one is going to be 6.2, and the second one is going to be 7.4, and let's see, check it. all right, great. Now they are asking about the 99 percentile confidence interval, so we're going to do exactly the same thing. The only thing we need to figure out that area, right? So let me repeat the graph. So I'm gonna graph it again so you can understand it better. Now, if I have, this is my normal distribution after the center limit theorem. So this is gonna be my x bar. The center here is going to be mu x bar, which is 6.8, and the standard deviation sigma x bar is going to be 2.1 divided by radical 45, and the area that I have here is 99% in between, so this area is going to be the confidence interval. Alright, so this area is 0.99, and then I want to figure out what is the tail. So I need to figure out this tail here. Actually works for both tails, but anyway. So remember, if C equals to 0.99, then this area over here, it would be 1 minus C divided by 2. Alright, and this is going to be 1 minus 0.99 divided by 2, and finally this is going to be equals to 0.0050. Alright, so this is the area that we have. Then what we're going to do once we figure out this area in here, so we want to figure out this number, what might be. Alright, that the lower end. So the lower end, we're going to go and plug in this area into the calculator, the left area, right? So second vars, and then you're going to go to inverse normal, enter. So this area is going to be 0.0050. The mean is going to stay the same, standard deviation is going to stay the same, and enter, and enter again, and this is going to give you 5.99, I guess, 4. All right, now I'm going to go and do the same thing. However, I want the upper end. So the upper end here, I need the total area again on the left side. So I need this total area in here. So I need this area from here all the way here, go up, and the total area, right? So what's it going to be, this total area? It's going to be 0.9900 plus this small tail over here, all right, which is 0.050, and this is going to be 0.9950. all right, so that's all what you're going to change. Let's see it. Second vars normal, inverse normal, enter. So I'm going to change this one. It's going to be 0.9950, and everything else stays the same. Enter, paste, and that's going to give you 7.606. all right, okay, let's go back to the question, plug in the numbers. So we want to round to 1 decimal place. So 5.99, if you round it, it's going to be 6.0, right? And the other one, 7.6, that's it already rounded, 7.6. And that's all, I think. Let's check it. Great, or not. All right, the answer is correct, but I don't need to put a 0. Okay, that's still correct. Great. Now, which is smaller? Explain why. All right. Obviously we have the answers here, right? So the smallest confidence interval, it would be, so this start from 6 all the way to 7.6. So the range is going to be 7.6 minus 6, which is 1.6. This start from 7.4, start from 6.2, goes all the way to 7.4. So the range will be 7.4 minus 6.2, that will be 1.2. Obviously 1.6 is greater, so the 99 percentile. So the 99 percentile here, confidence interval, is more of a chance that the mean is contained into the interval at the opposite, I guess, 95%. Oh, hold on. The 99% is smaller since, no, the 95% is smaller, all right, since it is less than the 99%. There you go. So this is the correct sentence, and that's it. All right, so I hope this will help.